Okay, we have a projectile. It's fired in such a way that its horizontal range is 6.0 times its maximum height. It asks us for the angle of projection. That is, the angle in which the projectile was thrown to achieve this result. This diagram shows, well, it's a bad diagram, but it's enough to get the point across. The maximum height is denoted as h. The horizontal range is denoted as 6h, 6 times the maximum height. I decided to use these two intervals from the start to the peak of the motion, which gives us 3h for our horizontal range. We do our given and required. We see what information we have, and we see how we can solve the problem based on that information. Horizontally, here's what we have. This is constant motion, so we only need these three variables. For our velocity, right, we denote the initial velocity as v. If we want the horizontal component, it's cos theta times v. Displacement 3h, and then time is 2. Then we have our vertical component. The vertical component for the initial velocity is sine theta times v. At the peak of its motion, our final velocity is 0. Displacement is h. Acceleration is negative g, because it's down, and then time is t. Setting up our equations, the first equation I use for horizontal motion is d equal to vt. Subbing in, we get 3h is equal to cos theta times vt. For the vertical motion, the first equation I use is d is equal to v naught times t plus 1/2 acceleration times t squared. Subbing in, we get this. Next, we have this equation, which is v final is equal to v naught plus acceleration times time. Subbing in, we get this 0 equals to sine theta v minus gt, and we isolate for t to get this. I boxed in all the important equations because these are the equations we're going to use to solve this question. To start our calculation, I use this first equation and second equation. I sub the second equation into the first equation to get 3 times sine theta vt minus 1/2 gt squared. And this is equal to cos theta vt. I distribute the t inside, I distribute the 3 inside the bracket. Then I use my third equation and sub in sine theta v divided by g wherever I see t. This looks very complicated, but things will simplify at the end, so just stick with me for this process. The first thing I do is I square this term, so we get sine squared theta v squared divided by g squared. And then this g term over here and this g squared term, one of the g's will cancel out. We have sine theta v times sine theta v for the first term, so we can turn that into sine squared theta v squared. And then I bring this g, this 1 over g to the outside. And then over here we have cos theta times sine theta times v squared, because we have two v terms right here, which can multiply together. My voice is dying a bit, but I just brought the rest of our g terms to the outside here. This step, we combine like terms, because sine squared theta v squared and sine squared theta v squared are common in our first and second term. Now this gives us this. I used basic fraction rules to combine these two fractions, and that gives this after all is said and done. From this step, the cancellation will occur here because we can cross multiply both sides, which should give us this. You get sine squared theta v squared divided by cos theta sine theta v squared. The v squared term on the top and bottom will cancel, and so will one of your sine theta terms on the top and bottom, which should leave you sine theta. It should leave you with sine theta divided by cos theta. Cross multiplying on the right, you get 1 over g divided by 3 over 2g, which is the same as saying 1 over g times 2g over 3. You take the reciprocal. This gives you this. Sine theta over cos theta is equal to 2 over 3. A very simple trig identity is that this is equal to tan theta. And we can evaluate this for theta by taking the inverse tangent of 2 over 3, which will give you some numerical value for your angle. Use your calculator to solve it, and you should get 33.690067. Round that to the proper amount of significant figures, and you're done. That is your solution to this question. So it looks complicated, but do enough practice and you should get familiar with these types of questions. Often things will cancel out, as you saw, and I hope that this question helped. This video helped.